So welcome back to our today's lecture number 7. So I think we will make a small vehicle on the lecture series 1. So first class we discussed about the vehicle parameters and then vehicle fundamentals, and then second class we discussed about what is meant by EV, electric vehicle, and then what are all the things available in electric vehicles, and then third class we discussed about motors, motor types, and then motor utilizations. And then fourth one is the basic hybrid mechanisms, what is meant by hybrid, and then what are all the combinations for making hybrid. This kind of things are discussed in fourth classes. And then fifth class, types of hybrid systems, series parallel and then series parallel. I think last video lecture I explained the series hybrid mechanism. Today class we will discuss about the parallel hybrid. So what is meant by parallel? Parallel is nothing but two different sources at a time. It will deliver the maximum amount of power and then it will give to the wheel. So I make a one block diagram. So this is the electric vehicle wheel, so the differential here, and then again electric vehicle wheel. So this one is called V1 and then this is called V2, and then differential here DG. Alright. So we have in a gearing arrangements here. So this is the common gear and then connected to shaft. So in this common gear we have two different kind of sources. First sources is nothing but it is a transmission system. It's connected here. So the transmission system connected to internal engine or a IC engine, internal combustion engine. So this is how the internal combustion engine power is delivered here and then transferred here, and then finally the power is going to distributed 4 wheels or a 2 wheels. If the vehicle is a 2-wheel drive, the power is transferred into 2 wheels. If the vehicle is 4-wheel drive, the power is transferred to 4 wheels. So and also we have in another sources that is called, this shaft is connected to here is motor. So at the same time motor also delivered the power here. So the motor also give the power to wheels. At the same time the motor need a power supply. That's why I am fixing this battery or an inverter here. Inverter is supplied by battery. So the power transfer like this. So one vehicle run by two different sources at a time with the help of gearing mechanism. Okay. So what will be the pros and the cons? The pros, the vehicle can experience the high power rating of torque. For example, the vehicle need more amount of power. This more amount of power is powered by motor. For example, this motor will give 75% of the power, remaining 25% of the power given by internal combustion engine. If we need the vehicle, for example, just assume that the vehicle motor rating, the vehicle need 1000 watts of power, but the battery has 50 watts. Remaining 50 watts taken from IC engine. Alright. So because this vehicle is not even loaded 100 watts at all the times. It will load 100 watts at particular or certain period or certain constraints or a certain conditions. So in that condition, if we are designing 1000 watts of a battery for running a 1000 watts of vehicle, so it will be a higher capital cost because the vehicle need not have this 1000 watts of capacity. That means 1000 watts power delivery content of the battery. So we can design the battery. We can cut off our battery cost. We can cut off our construction costs. So that's why we are using these two different kind of sources. So one sources is always run with the help of battery, motors, and then vehicle, and then another one will support whenever we need a internal combustion engine systems. This system will goes to here. So this is called as a parallel hybrid system. So in this parallel hybrid system, at a parallel time duration, it can give the power to electric vehicles. So this is called parallel hybrid system. So where we are using this parallel hybrid system? For example, all kind of domestic vehicles, all kind of transportation vehicles, we need a maximum power at particular time period. For example, initial conditions or a traffic condition or a hilly area conditions. So in that conditions, we need a maximum power. So due to that constraint, we cannot design our battery as a maximum power rating of battery. So that's why we are designing a battery 50% or a 25 to 75% of the maximum rating of motor. We are designing our batteries. So remaining power is taken from internal combustion engine. This internal combustion engine delivered 25% of the power. So this power is taken from internal combustion engine, gearing arrangements, and then gearing mechanism. So here this gearing mechanism will have two different kind of sources. For example, if need not the internal combustion engine EC, the gearing mechanism, it will be easily cut off the internal combustion engine input. It will driven by only battery, inverter, and then motor by vehicles. So if we need to, for example, the battery power is going to be 0, in that time we can run by internal combustion engine and then gearing to wheels. So this is called as a parallel hybrid systems. I hope you understood the concept of parallel hybrid system and then block diagram of parallel hybrid system and then working principle of parallel hybrid systems. So we will see on a 8th lecture the concept of series parallel concept. So in this series parallel concept we will see on a next class. So thanks for learning.